review sheet D, differentiating logs and e to the x. The questions on this video are not the same as those on the review sheet, but they are similar, and so if you work your way through the video, then it will help you with the questions on the review sheet. First one is differentiating any functions linked with e to the x or ln of x. So, differentiating with respect to x, and start with e to the x, e to the 5x. We differentiate 5x to get 5, and the e to the 5x also then remains the same. So you just get 5e to the 5x. In this case, it's e to the 5 multiplied by x, and e to the 5 is just a constant. It's like saying differentiate 8x or differentiate 19x. And so in this case, it just goes to the constant, the e to the 5, just like 8x would go to 8 or 19x would go to 19. If you've got ln of 5x, then the thing to do here is to use your rules of logs to get it into something that involves a ln of x. And so if it's a multiplication, you add logs, so ln of 5x is the same as ln of x add ln of 5. Ln of x differentiates to 1 over x, and ln of 5 is a constant, and when you differentiate a constant, it disappears, so you just get 1 over x. If you've got ln of x to the power of 5, then that is the same as 5 ln x. So when you differentiate it, you get 5 lots of your 1 over x, which is just 5 over x, because that's like 5 over 1 times 1 over x, it becomes 5 over x. If we had, let's say, 5 over x squared, we split it into a division, this is subtraction, so it's ln of 5 minus ln of x squared. And then for this part, putting the index in front, you get ln of 5 minus 2 ln x, and now we differentiate it. Ln of 5, so it's a constant, so it disappears, and ln of x goes to 1 over x, so minus 2 lots of ln of x becomes minus 2 times your 1 over x, which is minus 2 over x. Our next lot, tangents and normals. Okay, so we're on this example showing the equation of a normal to the curve at a particular point. So, if we want the normal or the tangent at a particular point, we want to find the coordinates of the point, both coordinates. So if x is 3, what is y? Well, y is e to the minus 3. So the x1, y1, the point on the curve, is 3e to the minus 3. That's its coordinates. x1 is 3, y1 is e to the minus 3. We also need to differentiate to find the gradient of the curve. And if you differentiate e to the minus x, you get minus e to the minus x, because differentiating minus x comes to minus 1. When x is 3, then this is minus e to the minus 3, so that tells you that the gradient of the curve at x equals 3 is minus e to the minus 3, and the gradient of the tangent is the same, it's minus e to the minus 3. For the normal, you use the negative reciprocal, so it's going to be the negative of 1 over this. Well, the negative divided by a negative becomes a positive, so you're left with 1 over e to the minus 3. And then, just the same as e to the minus 3 is 1 over e cubed, 1 over e to the minus 3 equals e cubed. Using y minus y1 is mx minus x1, we've got our gradient. We've got the point it goes through, so that tells us that y minus the y1, y minus e to the minus 3, is the gradient, e cubed, times x minus the x1, x minus 3. Now all we need to do is we're asked to put it in a particular form, so we expand it, e cubed x minus 3e cubed, move the e to the minus 3 across, so you get the equation in the correct form becomes y equals e cubed x plus e to the minus 3 minus 3e cubed. So that's one there has moved across here, and that means that when you compare it with this, that the k, the constant term, is e to the minus 3 take away 3e cubed. Stationary points. When the y coordinate of the stationary point, find the y coordinate of the stationary point for y equals 3e to the x plus e to the minus 3x, and then we've got to find out what type of stationary point it is. So the first thing is we differentiate it. Differentiate 3e to the x, it stays the same, because e to the x stays the same. Differentiate the e to the minus 3x, you differentiate the minus 3x, it becomes minus 3 in front, and the e to minus 3x stays there, so it becomes minus 3 e to the minus 3x, that part. Now, for a stationary point, that's 0. So we've got to solve this equals 0. And that's the difficult bit of the question, solving 3e to the x minus 3e to the minus 3x is 0. Okay, and so what we need to do here is you need to multiply through by e to the 3x. So you multiply through by e to the 3x, okay, then first of all, I've cancelled the 3's just to get e to the x minus e to the minus 3x. And now, if you multiply through by e to the 3x, then you should find that that one there, the e part disappears and it makes it nice and easy to solve. I'm not going to do that bit for you. Okay, you should get the y coordinate of the stationary point becomes 4. I'm not telling you what the x coordinate is. And then go back to the dy over dx equals 3e to the x minus 3e to the minus 3x, and then differentiate it again to get dy over dx squared, and then all you need to do is slot in the x value, not the y value, the x value of the stationary point into that, and you should see that it's a minimum. Okay, again, I'm not going to do that bit for you. Okay, well, so I hope that helps you with the review sheet. Good luck.